Hi everyone again. So I'm going to continue on topic 26. For first question we did sorry about that, we did the first derivative for velocity and the second derivative for acceleration. So I calculated them just in order to have the answer here. So the answer is for the yes, for this one is 363, and we round to 363.17, and we round to 363 meter. And here it was when I calculated, it was 2. For this one it was 3.3 I think meter per second, and we round to 3 meter per second. Okay, that. And also for acceleration, yes, for acceleration I have to substitute in so this is for that, and then for acceleration I have to substitute in here. So I have to do S prime, sorry, S double prime 4.3, and then I have to calculate. The answer is 98.12 meter per second squared, which will be round to 98.1 meter per second squared. Okay, so questions of this topic are not hard at all. So you can just, you have the displacement, you have the motion function, and you have to find the first derivative for velocity, substitute, calculate, and then meter per second, meter, kilometer per second, kilometer per minute, so kilometer per hour. So you have to include the limit. So include the unit, just depends on the what you see in the question. And also a statement, so a sentence you have to write, and that's it. Okay, so for let me see. So here I have the answer for this one, which is this one, and I have the answer for this one, which is this one, and I have the answer for this one, which is here. Okay, so first derivative, second derivative, and here it says find the velocity. So again here I can substitute there, and I can say, okay, so S prime at 3 is, I can write, okay, so minus 12 unit per second. Okay, unit per second. And here is prime 6 is 24, I think 24 unit per second. We didn't say, it didn't say, but I think it's meter. I think it's meter per second. Okay, and it says when the particle is at rest, so means when the first derivative or the velocity is 0. So you have to find those points, and you can see S prime, do I have, yes, S prime at 2 and S prime at 5 is 0. Okay, so now I continue here. So here, look at the function. The function is this, means something is just dropping off. It says a stone is dropping off from a cliff which is this much high, so 122.5 meter high. Okay, and depends on the gravity and all those things. So you have the formula here. Okay, so we don't talk about how did we find the formula and what is the reason, and so we don't talk about that part, we just do the math part. Okay, so find the velocity here. So when it says find the velocity, remember, when it says velocity, you have to find the first derivative. Okay, h prime is minus 2.4.9 t, which is minus 9.8 t. And then h prime at 1 is minus 9.8 meter per second, and h prime at 2 is 9.5, sorry, 9.8 times 2, which is 19.6 or negative meter per second. And why negative? Because the direction is down. Okay, so negative shows the direction. Okay, so here you are just finding the derivative. The function is not hard. The derivative is very easy derivative kind, and you just have to substitute. You just have to be careful about calculation. You just have to be careful about the unit. You can write it. Okay, good. So let me see. I just wanted to check something here, and yes, here is velocity. Yeah, and yes, here. Yeah. Okay. So now it says when the stone hit the ground. So what does this mean? Okay, what is h? H is height in meter. It says when hit the ground means height is 0. Okay, so I put h equals 0, which is 122.5 minus 4.9 t squared, and I can find the answer. Okay, so I have 4.9 t squared equal 122.5. And t squared is 1225, so 122.5 divided by 4.9. Okay, and t is radical that. Remember, mathematically I say plus minus because I have t squared, but in reality t is time and cannot be negative, so I just write the plus one. Okay, plus, and I do 122.5 divided by 4.9. I can find the answer. Okay, so it's radical 1225, 122.5 divided by 4.9. Okay, which is 5. Okay, so it's 5. Exactly at 5 seconds it hit the ground, right? So it is, let me see, this times this. Yes, okay, hit the ground at that time, 5 seconds. Okay, so I can write at 5 seconds the stone hits the ground. Okay, so I can write the sentence here, and you need to have the conclusion sentence. So at 5 seconds the stone hits the ground. Okay, I can change that, and I can go here, I can go here, I do this, and I do this. Okay, and here you can write velocity is, so here you can write velocity is minus 9.8 meter per second, or velocity at 1 second. At 1s is this, and at 2 seconds is minus 19.6 meter per second. Okay, so you have to have the sentence. Okay, so right, so maybe right now that I'm doing with the video, so I don't do all the sentences, but I will add them later. So for example, here you have to say at t equal 2 and 5 seconds the particle is at rest. And you all know, and I told you several times, don't write the answer is, sorry, don't write the answer is, for example, don't write the answer is 2 and 5. So this doesn't have any meaning. So when you write conclusion, the conclusion should give just idea that what did you do there. Okay, so you can have that. And again here, so you can write the velocity is that. So make sure to add the sentence when you are writing. It's very important. It's very important when you are doing your lab work. Okay, you have to be able to explain. So with what velocity will hit the ground? Okay, so what does this mean? It means at that time that it hits the ground, which is s equal 5. Okay, so s is equal 5, we found it. Sorry, t equal 5, so 5 seconds. Okay, So at that time, what is the velocity? So you have to find the function of the velocity, which I did. Okay, the function of the velocity is minus 9.8. Okay, so I do h prime, which is minus 9.8 t, and h prime, and this means h prime at 5, which is 9.8 times 5. Okay, that's minus 49 meter per second. So it means when it's hitting the ground, it's hitting the ground with this velocity. Okay, so you have to write the sentence here. Okay, and explain. So what else? So here, this is a Wiley plus question that I wanted to explain. Actually, the question says this is the function of the motion. Okay, so a particle moving along. Okay, from 0 to 5 seconds. How much it's moving from 0 to 5 seconds? And a student, they used to do this when they wanted to calculate. They used to do this. So it's s5 minus s0. Okay, but it's not like that. I have to see the motion, I have to see the function, how it's moving, how it's changing. Okay, so we first think about this, but it's wrong. Okay, look at the graph. When I make the graph, look at this. When I look at the graph, okay, so here is from 0 to 5. But from 0 to 5, it's coming here and it's then going there. So if I say, for example, if I say at 5, what happened at 5? So 2 times 5 cubed minus 7 times 25, which is 75. Okay, so at 5 is here. Yes, it's here. It goes to here, 75. Okay, look at this. Okay, so a student, they used to calculate this way. They used to do the 75, which was that, minus 0. Wrong, because the motion is like that. So it starts from 0, yes, I know, but it goes to negative and then goes up. So it means you have a part. If you do just 75 minus, means you are just calculating this part. Okay, but you have to add this and this as well, because it's going down and coming up. Okay, this is Wiley plus question. Says the function of the motion of a particle is this. This function describes the position of a particle moving along a coordinate line, where s is in feet and t is second. Okay, so unit of the motion is feet and the other one time second. Find the total distance. So I said at the beginning, they used to try this, but it's wrong. No, you have to see. So how do you have to do it? You have to find this point. You have to find the time which this minimum is happening, and then you can find the answer. How do you find the time that minimum is happening? How do you find the point of x-axis which minimum is happening there? Yes, we know the first derivative. You find the first derivative, put equal 0, you find that time. Okay, so it's s prime equals 0. Okay, so s prime t equals 0. So I find 6t squared minus 14t equals 0. So it's t times 6t minus 14 equals 0. T is equal 0 and t is equal 0. It doesn't work for me because look at this. Yes, here I have a maximum, but t is not negative. So this point is not really a maximum for me. Okay, it just shows on the graph and it's mathematically maximum, but not in reality. And how about the other t? The other t is 14 divided by 6, which is 7 divided by 3. Okay, so 7 divided by 3 is where the minimum is happening. Okay, and I can see When I look at the question, it says, okay, this is the function of motion from 0 to 5. So I do, okay, S5 minus S0, but this is not the answer. The Wiley plus doesn't accept. But when I make the graph, I see I have a minimum which is negative. So it goes down and then comes up. So that's why I cannot use S5 minus S0, because I have to include that part. I have to include these two parts. I have to include this one and this one. Okay, so now I find the answer here, and this is the point where minimum is happening, which is 2 point something, 2 point something here. See, look at this, 2 point this, 2.3, which is here, and then I have to find S 7.3 minus S0. You have to find the answer here, plus S plus S5 minus S7 over 3. Okay, I have to find the answer, and for both of them I need to use absolute value, because it would be negative, because a part is negative. But when I say how much it's moving, it must be, I have to consider the positive part. Okay, this is a Wiley plus question that many students asked, so I added to the lesson. Okay, and that's a very good question here. Okay, so don't forget absolute value, because a part is negative, and when I say how much is moving, so I don't say minus 2 meters, so it doesn't make any sense. Okay, it must be positive. What else? Okay, so practice questions. A car moves according to the equation. Okay, so a car is moving according to equation here. Okay, so so a car is moving according to the equation, which is this one. Yes, this is the equation, so maybe I can zoom. That's here. So how far does the car go in the first 10 seconds? So you just have to substitute 10. Okay, so S10. What is S10? Okay, so 250 multiple 100 minus 5 divided by 4 times 10,000, right? Which is 12,500, right? Meter. Is it? It is measured in that. Yes, meter. Okay. So this is the answer. And 10 second. Yes, you just have to substitute and make sure if it is in the in the test, you have to show me the answer. So you have to show this way. So you have to do 250 10 squared minus 5 over 4 10 power 4, which is this. Okay, and then write the sentence, a conclusion sentence. So what is maximum speed? This is very beautiful, just very beautiful question, beautiful part. What is maximum speed? So let's think about it. I want to find maximum, but maximum of speed, not maximum of the function. Okay, remember, when I have fx, in order to find maximum, I find f prime x and I put it equal 0. Then I find x, then I find y. How? I go here and then I check with double prime and I see either minimum or maximum. But here you don't have f. It says maximum of speed. Means you first have to go to your function. Here your function is not s. You don't want maximum of s. You want maximum of s prime. So first you have to find s prime. So what is s prime? Okay, so s prime is, because it says speed, s prime is 500 t minus 5t cubed, right? 5t cubed. Okay, this is your function. Remember, this is like this. Where is, yeah, this one is like this one. Now I have to go to the derivative, s double prime. So make sure you understand the question. It doesn't want maximum of function. It wants maximum of speed. So first I have to go to my function, which is the speed, which is the first derivative. And now I'll do the second derivative. And this one is like this one, equal 0. Okay, so 500 minus 15t squared equals 0. Now what is t? When I find t is 500 divided by 15, and I use radical. Okay, so it is t is 5.77 second. Am I right for second? Yes. Okay, check this. When I find this, I'm finding this one. Now if I want to find y, I have to substitute here because it says maximum speed. This is my, now this is my speed is the function. Speed is my function now. Speed is what I start. Okay, so y is, I substitute. Okay, so it's 500 times, so one more time I can find my, so this is that, this divided by this, and yes. Okay, so this one and this point, this is my point, so I times it with 500 minus 5 times 5.7735 cubed. Yes. Okay, and this is 1924.5. Okay, 1924.5 is y, which is the speed. Okay, now this is the speed. Meter per second. How do I know its maximum? How do I know its maximum? Okay, I find third derivative, but here third derivative is second derivative. Okay, second derivative test. Why? Because the first derivative is my function now. Okay, so I started from there. Okay, so I found this, and this I can make it green just in order to say that. And then I find s double, so s triple prime. So s triple prime is 500. No, sorry. Okay, minus 30t. When I do s triple prime, I do 5.77. I see minus 30 times 5.77 is negative. Therefore, this is maximum. This is maximum. Okay, now this one is the same as this one. Okay, for a function, first I go to f prime, I find equal 0, then I go to f double prime, and I say maximum or minimum. Here I have s prime first, then I go to s double prime, find my points for s double prime because it says maximum speed, and then I check s triple prime and I say maximum or minimum, and this is maximum because s triple prime is negative, and when double prime is negative, at that point it's maximum. But here triple prime is my double prime for a speed. Okay, so I can say maximum speed is, so maximum speed is, I can just change my, so let me see, I can close the window. Okay, so my maximum speed is 1 maximum speed is 1924.5 meter per second. That's answer. How far has the car moved when its maximum speed is reached? So you have to say, see, it says when. So what was the time? Okay, maximum speed was 577. Was 577. So it means I have to find S at 577. So S at 577 is the answer. So I substitute S 577, or I substitute S 5773. I think it was 35. Yeah, because I don't want rounding and rounding, so I include more points. Okay, and I find the answer. And the unit will be meter. The unit will be meter, if I'm correct. Yes, the unit will be meter, and you have to add a sentence. So in these kind of questions, you have to understand the question. So what's going on? Okay. So here, and how about that? This question. Before, we used to have a lesson about rotational motion. We used to have how many radian, how many this, how many degrees, and those things. So we removed that part, but still we have this part here, and it's not bad to talk about it because it's related to just derivative. Okay, see, I have a function for rotational motion. The function, I usually show it with theta. Okay, theta is ft. This is rotational motion. Angular motion, when something is just like going circle. Look at this. For example, I start from here and it goes like a circle around the circle. Okay, so this is something moving rotational. So I start from here and like a for example a wheel. Okay, so something is moving but in around the circle, like a circular or angular, so I would say. Okay, so again, the first derivative is angular velocity. Look at this. The first derivative is angular velocity. So this one. The second derivative is angular acceleration. Okay, and I show it with this guy, alpha and omega. Okay, so alpha and omega, angular velocity and angular acceleration. Okay, so I know we didn't do too many questions on that, but on that topic before. We didn't talk what is radian, what is those things, but still we can do this question. The angular displacement of a rotating body is something like a wheel, something is rotating, okay, around the circle, is given by that theta, and it's radian. Maybe I can just make it more clear for you to say, when I start from here and I reach to the same point, I go 360 degree, or I go 2 pi radian, or I go 400 gradian. But you don't see gradian. Okay, so we used to do radian and degree, but we removed them from the lesson, so we don't have them, but still we can do this question. Okay, so it says how many radian. So radian is the unit for the motion. Okay, so and then you have to say for angular velocity, you have to say radian per second, and for this one you have to say radian per second squared. It's very easy. You just have to find theta prime, okay, which is 44.8 times 3. Okay, so it's 134.4 t squared plus 29.3 times 2, which is 58.6 t, and then I do double prime, which is 134.4 times 2, so 268.8 t plus 58.6. So this is for velocity and this is for acceleration. One of them radian per second, one of them radian per second squared. and you have to substitute that point, that second. How many seconds? 4.25 seconds. That's it. Okay, so we didn't do too many questions on this. We used to do a lesson, and then when we came here, so we just did angular velocity, angular displacement, acceleration. But this is just what you can do now, because you know how to do by derivative. Okay, the first derivative, the second derivative, and you know the answer. Okay, so I am done with this lesson, topic 26. Next, I go to topic 27, which is going to be, okay, let me just add it here, and then I stop, and I can continue after. So topic 27 is related rates. Okay, so we will do it later, and so we will talk about it later. Okay, thank you so much. This is just application of derivative. Okay, so application of derivative, we continue, and then we go to topic, after that is topic how to find optimization, how to find maximum, how to make minimum of just something application questions, and then we go to antiderivative, and then we are done. Okay, so thank you so much. Bye.